Hello students, I again welcome all of you in my chemistry class in the class 9th chapter number 3 atoms and molecule. In the very first chapter we have discussed about that what is the law of conservation of mass. हमने देखा वहाँ पर कि mass cannot be created nor be destroyed. Second law we have saw that law of constant proportion. According to this law, all substance in any reaction substance in any compound, the atoms are joined in a constant proportion. Again we saw that what is Dalton's atomic theory, what are their postulates, what are their drawbacks, and also we gone through the atoms, what are atoms and how can we find out atoms. The second part we are going to start today is the second part. In second part our goal is that to identify the symbols of elements. What are the symbols? What is the why we needed to make any symbol of any elements? What is atomic mass? What is molecule? What is ion? Types of ion, and what we mean to valency. So this is our second part goal of the today's class. Students, we know that in our class we are known by our own names and everybody have their own names. If you go to the history of these symbols, first of all Virgilius given the concept of symbols, but what there is in the figure is given was proposed by Dalton. Dalton's given different types of symbols for different elements. For example, he given hydrogen like this, carbon like this, oxygen this, phosphorus like this, copper like this, and this is the very initial stage. By doing so, the concept of symbol of elements or atoms started. Students, one new name you will see in your board, that is IUPAC, International Union of Pure and Applied Chemistry. It is an organization, it is the head of organization for the chemistry, and according to this organization, the IUPAC, symbol of an element is either the first letter of the name of the element or the first two letters of the element. According to IUPAC, any element, the symbol of the any element is either its first letter of the name or the first two letters of the name. But there in cases there are two letters, then the first letter is the capital letter and second letter is the small letter. Let us see, I have taken some beautiful picture for all of you to understand the symbols. See this, I have already told IUPAC first of all says that letters are used to represent the elements and these letters are called as symbols. So this C is the symbol of carbon. So it is a symbol. The letters are used. IUPAC stated that the names of the element would be from first letter. So see this carbon C, boron B, oxygen O, hydrogen H, nitrogen N, and sulfur S. So all are their first names only. So this is the one theory of IUPAC, that the elements name should be of their first name and it should be always in capital letter or in uppercase. According to second rule of the IUPAC, if the name is given into two words, the first would be the capital letter and second will be the lowercase or small letter. For example, aluminium Al, chlorine Cl, argon Ar, beryllium Be. So means according to IUPAC, if you are taking two names, two letters, first will be the uppercase and second will be lowercase. This is the IUPAC name and symbol. come to the topic. Sometimes the symbols are derived from the Latin words. Very important, dear students. Many times some questions are asked to you in your examination that why the gold is taken as AU, not AG, RG. Suppose this, see this example, gold whose symbol is AU. So many times question comes. So for this understanding this, if I am starting this, you have a doubt that why gold is written as AU, not G or GL or GO. So for that I would like to tell you that some elements have Latin names. First and second letter of the Latin name used to represent the symbol. For example, antimony, the Latin name is stibium. That's why the symbol SB is given. Copper, cuprum, Cu is given. Gold, Latin name is aurum. That's why AU is given, not G or GO or GL, other name is given. Iron, ferrum is Latin name, and that's why Fe name is Fe symbol is given. So by doing so, you can understand there are certain elements whose name is given on the basis of their Latin names. So I think it would be very clear to you that symbols are also given on the names of their Latin names, and their Latin names is the reason for the symbol like Mercury Sg, not Me or Mr, because this Mercury is derived from a word. This Sg symbol is derived from a Latin word hydrosium. So we have to be very clear that the IPSC name is also given on the basis of Latin name also. Next is the very important topic, that is atomic mass. The Dalton atomic mass theory suggested that each element has a distinguished atomic mass. With this theory, the law of constant proportion could be explained. But it is indeed difficult to evaluate the mass of an element since the size of the element is relatively very small. Dear students, we know that atoms are very small sized, and that's why it is very difficult to know their mass. That's why scientists have taken an standard atoms. That's why the scientists have taken a standard mass of an element and they compared it. For example, suppose this is suppose this is A element, suppose this is an atom A is there, and it is compared with X, Y, Z, and we can compare like it is heavy, it is heavy, it is lighter, it is heavier than this, it is lighter than this, but its mass is fixed. So this is called relative. We are just correlating with this. So atomic mass can be defined as the one atomic mass unit is a mass unit equal to the exactly 1/12 of the mass of an atom of carbon. The relative atomic mass of element have been found to be respect of carbon 12. Yes, I would like to clarify your doubt that in earlier stage oxygen 116 is taken. Here I would like to say oxygen 16 is taken, but that as the time oxygen, because oxygen react with the large number of elements, that's why oxygen was not taken as it. But in 1961 carbon 12 C12 is considered as the standard atom. I told now this, suppose this is a standard element, or we are comparing with this to this element, this element, this element. So similarly oxygen was discarded and carbon 12 was considered as the standard atoms. Its atomic mass is 12 atomic mass unit. So we can define as the atomic mass as the number of times of an atom of the number of times of an atom of an element is heavier than 1/12 of the carbon atom. Means suppose helium, let us 4U, it means helium is 4th time heavier than 1/12 of, if you consider that this the Helium has atomic mass of 4 unit. What does mean of 4 unit? 4 unit means helium is 4 times heavier than 1/12 of carbon 12. Means we are comparing from, इसका मतलब है बच्चों कि हम कार्बन 12 से कंपेयर कर रहे हैं हीलियम का, कि हीलियम 4 टाइम हैवियर है किसके, कार्बन 12 के। तो अर्थात अगर हम किसी दूसरा उदाहरण ले ले, मान लीजिए हमने सोडियम ले लिया, सोडियम का एटॉमिक मास 23 होता है, इसका मतलब सोडियम इज 23 टाइम्स हैवियर देन 1/12 ऑफ कार्बन 12. So I think it would be very clear that atomic mass is the number of times of an atom of an element is heavier than 1/12 of the carbon atom. Means I stated that helium atomic mass is 4 unit. It means helium is 4 times heavier than 1/12 of the carbon 12 atom. If I say that sodium atomic mass is 23, it means this sodium is 23 times heavier than 1/12 of the carbon 12 atom. So we can see this atomic mass is the number of times of an element of an atom of an element is heavier than 1/12. For example, sodium atomic mass is 23. It means sodium is 23 times heavier than 1/12 of carbon 12 atom. In simple language, we can say that atomic mass of an element is number of times an atom of an element is heavier than 1/12 of atom. We have already discussed in previous slide. So these are the some examples of atomic mass. For example, hydrogen atomic mass is 1, carbon atomic mass is 12, nitrogen is 14, oxygen is 16, sodium is 23, magnesium is 24, sulfur is 32, and chlorine is 35.5. So if you go, as soon as you are trying, you will remember it, because many times you have to know the molecular mass, atomic mass, so many things we will study. So these atomic mass are required to solve the questions. Now question comes, can atoms exist independently? Dear students, atoms cannot survive independently. So atoms can join together to form molecules. Dear students, there are some elements like noble gases like helium, neon, argon, krypton, so many things. They can exist because they cannot react. They can exist independently, but other elements are not exist independently. For example, sulfur 8 means 8 atoms of sulfur when come together, that's why then they can exist. That's why atoms do not exist independently, while these noble gases exist because they do not react with anything. That's why atoms cannot exist independently. Next topic is molecule. Earlier I told you all that molecules is a collection of various atoms that combine chemically with each other. These, for example, you can see, first after you see this, then I will discuss it. You see this one matter is there, this is means, see this, when atom joined with atom, they forms molecule. One atom is this and another is this, one is this, another is this. When they combine together, they forms molecules. I think you are getting me what I want to convey to you. So atoms are the same element, are different elements that can bind together to form molecules. So when two atoms join together, they forms molecule. For example, oxygen O2. O2 means it is a molecule. O plus O. Hydrogen H plus H. So this is called molecule and this is called atoms. This O is atom and this O2 is molecule. Getting me? Okay. So if you see the molecules of element are also there, I already explained that H plus H is give rise to H2. So this is the molecule of element. This is one element, another element. The molecule of compound is similarly for example, hydrogen combined with chlorine, they forms HCl. So this is a molecule of compound and this is a molecule of element, because element are combining together form the molecules. Here again elements are molecules of compounds contain two or more different elements. When two different elements join together, they form molecule of compound. When these two same type of atoms combine together, they forms element of molecule of elements. See, some examples are there. You can see that sodium, potassium. So these are the smallest particle. The smallest particle of elements are a compound that can exist independently. So these are the things we already told that this noble gases can exist independently, but these atoms are not exist independently because they need some. For example, hydrogen is H2, oxygen is this. This is the molecule, and this is the atoms. Okay, come to the next topic. Atomicity, very important topic. One must question comes in your examination. What is atomicity? Number of atoms in a molecule of an element is called atomicity. For example, helium is a monoatomic, oxygen is a diatomic. Means किसी भी एलिमेंट में, किसी भी मॉलिक्यूल में कितने एटम्स जुड़े हुए हैं, दैट इज कॉल्ड एटॉमिसिटी. फॉर एग्जांपल O2 मींस O2 में हाउ मच ऑक्सीजन आर टुगेदर, O प्लस O, तो इसकी एटॉमिसिटी क्या होगी? 2, मींस इट इज ए डाइएटॉमिक. हीलियम ओनली 1, सो इट इज मोनोएटॉमिक. सल्फर पॉलीएटॉमिक बिकॉज 8 एटम्स आर. ओजोन ट्राइएटॉमिc. So I think you are getting me. My point is that the number of atoms of in a molecules of an element is called atomicity of that element, that compound. Means oxygen, there are 2 atoms are joined together. That's why it is a diatomic. While helium only 1 is there. That's why it is monoatomic. Sulfur, it is 8 atoms are joined together. Then they forms one sulfur molecule. So it is polyatomic. Ozone, there are 3 atoms of oxygen joined together, they forms triatomic. So the number of atoms in a molecule of an element is called atomicity. So I have already discussed in previous slide, like monoatomics, all the metals are in single stage. Diatomics, like other gases like oxygen, nitrogen. When an element consists of 2 atoms, it is diatomic. When an element comprises of single atom, it is called monoatomic. Triatomics means when 3 atoms are together joined to form a compound. Tetra 4, and polyatomic means more than 2. So hydrogen is a diatomic, oxygen is a diatomic, but phosphorus is a polyatomic because 4 atoms of phosphorus make one phosphorus molecule. That's why it is also called tetraatomic. So in previous slide we have seen that the oxygen is diatomic, chlorine is a diatomic, hydrogen is a diatomic, sodium is a diatomic, phosphorus is a tetraatomic, and sulfur is a octatomic. Means polyatomic compounds are there. So next is the molecule of compounds. Molecule of compounds constitute the atoms of different elements that combine together in a fixed proportion. For example, water comprises of 2 atoms of hydrogen and 1 atom of oxygen. For example, you see this figure, I have taken some figures. The molecule of compound is what? For water, this hydrogen and oxygen are combining element, and when 2 atoms of hydrogen and 1 atom of oxygen combine together, they forms water. Similarly, in ammonia, when the combining elements are nitrogen and hydrogen, 1 nitrogen and 3 hydrogens combine together, they forms ammonia. CO2, carbon dioxide, carbon and oxygen is the combining element. 1 carbon and 2 oxygen combine together to forms carbon dioxide. Similarly, all these things are given, so they are in fixed proportion always. Next is the very important, many times you are getting confused, what are cation, what are anions. So I am going to explain what are ions. The charge species are known as ions. Any charge species any element that have charge, that is called as ions. It may be positive charge, it may be negative charge. For example, see, this is one crystal of sodium chloride, and if you go see this is sodium and this is chlorine. So it has positive charge and it has negative charge. So they are called as ions. The ions are of two types, cation and anions. So let us one by one will see. So any charge species are known as ions. Already told that ions are of two types, cation and anions. The cations are the generally positively charged elements. If you see this figure, the sodium ion has a positive charge. They are positively charged and that's why they are called as cations. When an atom loses negative charges, therefore they are always have negative charges less than normal atoms. For example, sodium lose one electrons, that's why it has a positive charge. But in the another example you can see that there is minus charge, means they are called anions. In next slide we will see anions means they have negative charge. So the positive charge ions are called as cations and negatively charged ions are called anions. So we have seen in the previous slide, again I am going to explain that anions are those ions which have negatively charged. So you keep in mind that negatively charged ions are called as anions. For example, chloride ion is a anion. So next topic is what is valency. Many times as the class will increase, you will get confused what is valency. So here you try to understand what is valency. The combining power or capacity of an element is known as its valency. For ions, the charge indicates the valency of ions. I told sodium ions. It indicates that valency of sodium is +1. This one electron is able to take parts in the reaction. So combining power or capacity of an element is known as the valency of element. Means how many charge is there, that shows that would be the valency of. If we see that Ca++ means it has two valency. Are you getting me? So this is about the valency. So in this chapter, in this class, we have studied that a molecule is a substance, the smallest particle of an element, compound capable of independent existence under ordinary conditions. When atoms combine with each other, they forms. When two atoms combine with each other, they forms molecule. Symbols, I already told in our class we are taken by our own names. Similarly, IUPAC have given the elements on different types of names, on different symbols. The symbols are important to understand, to know them. The first letter of the element would be its symbol. Sometimes two letters would be given. First would be the uppercase and another second would be a lowercase. The number of atoms in a molecule is called atomicity of that element. For example, oxygen is there, means its atomicity is 2. Sulfur is there, its atomicity is 8. Phosphorus is P4 is there, its atomicity is 4. Means how many atoms are united together to form one molecule. That is called its atomicity. And the charge found on any element is called as ions. Ions are of two types, cation and anion. So we in a very brief way we see that the atoms and molecules chapter. This is the second part of the chapter, and we'll see the remaining part in the third part of the chapters. Now there is some questions for you. You try to solve it at your home. Thank you.